troubleshooting for H.248. So we have configured everything now in our system. We have configured our MGC interface towards the media gateway controller. We configured the TDM lines, which are controlled again by the media gateway controller. We configured an RTP range. Then we added some signaling information. So if it's required, then you can do your MTP2, M2UA signaling. And then you have also your IUA signaling in there. All right, so here we'll show, once you have configured all of this, how we can troubleshoot these things and understand what is wrong, either in the configuration or elsewhere. So of course, the first thing we will check for is the status. And we've shown in the different portions of the installation, what is the status we want to look at for each of the modules of the system. So we will go through this, make sure we didn't miss anything. Then we will go to the signaling traces, see how to capture signaling traces for H.248, M2UA, MTP2. So we already talked about some of this before. Let me just make Joshua, which has just joined here as host. Hello. You braved the weather.
Yeah, we've got a tropical storm hitting us, and I was not ready for how bad that traffic was out there.
Very good. That's okay. Thank you very much. We're just starting. So here
Awesome.
we're at the signaling traces. So M2UA, MTP2, IUA, H.248. So we can capture all of these traces and have a better understanding of what's going on. This helps us to find a lot of cases of maybe IP errors or port errors or in the configuration, so stuff like that. So it can, this of course is helpful a lot. We have also the reports or what we call our TB report. So this gives you information about the system. So we'll show you some of that. Audit logs, we talked about it already, but it's very important when we configure the system to understand what was modified, especially over time, and who modified the information. Then we have, let's say I put troubleshooting, but it's like low-level troubleshooting, where we can see, with the console commands, get more information about the system. Then we have the media traces. So this allows us to capture what is going on the media level. So if everything else is verified and there's no other errors, we can also go and capture a media trace. This helps us in some cases. So if I start with the status, you can go in the global status page. If you click on this, you saw many times in the previous or demonstration that we did, you see all the status of everything that is in the system. But things that you might want to look at is these ones here. They are called media only. And the reason it's called media only is that when the media gateway controller controls the media gateway, it allocates media resources. So you could have TDM resources, RTP resources, and then multiple of them are created, attached together. And you will see here a current number of media allocation on the system. You will have the number per second that are created here, and the highest number of media that were ever allocated on the system. So if your system is fully occupied, you will get the maximum value of that device here. Okay, the other ones here are when we control the signaling. So if we have a combined MGC and standalone in the same device, you could see some answered calls here. But in our cases, it should be only here, media only. There's some databases on the system. If you have a 1+1 system, you will have 2 databases, one running on each system. And this includes all the configuration of the system. Okay, so you can see if it's up and ready. So this, of course, should always be up and ready. If it is not ready, it's possible to go on the console of the device and restart the database, for example. So we can show you maybe some commands of databases that we can do later. But normally we should just see this up and running normally. Okay, so you get a global view of this. Then we have here, if we go down in the configuration, if you click on hardware units and the hardware unit status, the hardware units is what we described as the device that is carrying the TDM and the RTP streams, and also does the SIG-TRAN processing is also done on the hardware unit. So this is also, sometimes you will see in the documentation, it's called the Telecom unit. So this is the low-level system running a real-time operating system, and we'll show you in other slides what it looks like. If you have a standalone system, you will see only one of those devices here, okay, and they should be here like ready active. If you have a 1+1 system, well, both of them should be ready and one of them active. That's the one that's currently carrying the traffic. And the other one is just waiting to be taken over by the system. Right? And this what you have to understand is this is the telecom portion of the device. So this is different than what is running on the internal host of the system. Okay. If ever you are upgrading the system, you would see this here because when you install a new version, it will update the firmware on the device. And this will go to yes and will slowly update. It takes about the firmware here. It can be done while the system is running and processing traffic, but it takes around 10 minutes to download the firmware on the unit. Once the firmware is on the unit and you want to upgrade to that new version, it takes only a reboot of this telecom. There's some licenses on the devices. Well, most of our customers, they have always permanent licenses, and so this will remain false all the time. But in some cases, we provide some temporary licenses, and then you would see, well, not exactly here, but you will see if you click on the hardware telecom unit, you will see how much time you have left on the license, and if it's completely expired, then it's going to appear here. You have on a 1+1 system like this, you have multiple CPUs. You have CPUs on the internal host, and you have CPUs on the telecom units themselves. There's 2 CPUs on these telecom units, on each of the telecom unit in the system. And you can see here the percentage of CPU usage of the telecom units here. In a system like in a media gateway control environment, this should remain pretty low in a configuration. So you can monitor this either by looking at the web portal like we show here or in the SNMP information to see if the CPU usage is stable. If you click on that unit, one of the 2 units, you will get to an additional page like this. This additional page will show you the states of the devices. So you get all kinds of states here, but normally it should be like ready and active. And then you get below here, you have license information and these. Normally, we don't need to go in these information, but if ever the unit is not ready, then you could look at what is going on here. The usage is what we just saw, the CPU usage, but also we have fans and power supplies, which are monitored here. So you can see all of this if you click on these elements. And then license features is what is available on the device. Most of the things are licensed. The only maybe 2 things I would say is additional on the devices. One is the SAS license for the media gateway controller interface. The other one is MTP2 links. Okay, so if you need to have MTP2 links on the device, you need to license those. Otherwise, everything is always licensed on the device for the whole system. So now we have the complete hardware units. You see if it's running fine, and then in the low-level troubleshooting, we'll see there's other commands we can do to troubleshoot that, but this is to see the upper level status of these devices. TDM line interfaces. This is the T1s, E1s, OC3, STM1 configuration. So we saw how to configure this. And then if you click on the status here, you'll be able to see if it's running normally. So you will see here appearing loss of signal. So if you see loss of signal, it means that the signal is not detected at all. Okay, so for example, on an OC3, it could be connected the wrong way, so RX on TX, or just it's not the correct signal that is coming in. Okay, so if you connect a STM1 on an OC3, then and let's say you connect a STM1 on and you do an OC3 configuration, this is not gonna work. You'll see loss of signal here. Same thing if you have a T1. If you don't connect the T1 correctly, you will see loss of signal here. If you connect a T1 on an E1, for example, you will get a loss of frame. Or if there's too many errors on the line, you will also see loss of frame. But these are like major alarms, so that really when it's not running well at all. Okay. The remote alarm indication here is the remote side telling you that you are not sending the information. Okay, so RAI is still interesting to see because you know that you are connected somewhere, and you know the other side tells you that he's not receiving the data you're sending him. Okay, so you need to check maybe the physical line to see if it's being transmitted correctly. But there's also some tests that can be done, and we'll use the RAI alarm. And I will show you on the next page. Alarm indication signal, it's the remote end that is telling us that the upstream is down. Okay, so you are connected somewhere, and that somewhere is connected to another device. The somewhere you're connected tells you that the upper device is not working. Okay, so alarm indication signal is normally a MUX or something like that that tells you, well, don't try to make it work. It's not working upstream. Okay, so these are important information that helps us to troubleshoot the lines. If you click on one of those T1s, you can increase the trace level here and do a refresh, and you will see more information about what is going on here. So at 0, it's full details. And then you can get all the information like this. The slips are when your clocking is not good. So let's say you have configured your bits clock on the system, and then the bits clock is down. Then you may have slips because there's no other clocks in the system. Okay? So like I was explaining before, when you get a slip, it's not critical for many things, right? So if you have a voice conversation, you will just get a small glitch. If you have a MTP2 link and you have a slip, it may corrupt the MTP2 link, signaling packet, but it will be retransmitted at the MTP3 level, so it's not so bad. The only thing which is more tricky is when you have a modem or a fax connection and you get slips. This is more difficult to recover. Right? So especially if you're using a lot of modem and fax, it's important to have a good clock into the system. Other things we see sometimes is like code violations. That's when we have errors on the line. But some errors, but not enough necessarily to make a major alarm. Yeah, and then there was the sorry, this is for resetting the status. So if you want to reset status, you need to click here and then refresh, and this will clear all the errors that you had. So like I said before as well, when you connect and unconnect the devices, it's going to create a lot of errors. And then if you know your system is stable, you can then reset all these status. Some of the counters, well, most of the counters will remain forever, right? So if you have an error that occurred 3 weeks ago, it's still going to be shown there. Maybe you want to clear it at some point. The T1 debugging, T1 or E1, but it's also available in other layers. So you can do this at the DS3 and also at the OC3 layer. It helps you to debug the T1. So here you can change this information here and apply the state. So for example, or by default you have, whoops, by default you have none. So that means there's no loopback in the system. If you do a generate LOS, you will bring down the transmit. And if you do a line or a payload loopback, you will send back the information you receive. So this helps you to troubleshoot the system. For example, if you send, if you have a connection end-to-end between you and the remote device, you can simulate a loss of signal. So that means you stop transmitting, he will see a loss of signal. And here on the receive side, we'll get a remote alarm indication. So when we have this, and you look at the remote end and you say, yeah, I'm seeing a loss of signal. And here, yes, I'm seeing a remote alarm indication. This gives you a good idea that you're connected at the right place into the network. If you do the line or loopback, line or payload loopback, here, so you set, for example, a line loopback on this side. So that means everything that is being sent will be received here. Right? So normally this happens when you will use this when the other side doesn't see your signal, right? So it sees maybe a loss of frame or something like this, right? Or a lot of code violations. Or so if it sees any type of error, you can use a line loopback like this. On this side, you will still see the state of the received signal. So you will see it okay, probably if it's good on this side. If you don't see it okay, then we need to use other tools to debug this. If you see okay, then you need to see on the other side, when you do a line loopback, do you see it bringing up and being okay? So if that's the case, then it means what we are sending here normally is not compatible. So maybe we need to change the framing of the configuration here or the line encoding, or it could be these kinds of things. It can help us here to debug those T1 lines. You can do the same with the, like I said, with the OC3 to help us troubleshoot the system. This is at the OC3 level, so you have the same type of errors at the OC3 level. If you look at the OC3 status here, you get if it's up here, but here we see there's a lot of errors. So if we put the trace level lower, we can see what type of errors these are. Normally in a good system, you don't see any errors, right? It should be 0. So if your system is connected correctly, everywhere I connect to, I look at the OC3 connection, it's always 0. So it's important that the setup, the initial setup is done correctly so that we don't get any errors here. Here is the loopback, just as we saw, and the laser on, which I will show in a second. Here, protection activated, we have our APS mode, and this we should show in when you do your demo, Joshua. You should show the protection mode. Again, we could try the test again because now we made it work, right? The APS.
Yeah, we fixed the APS, so we can test it now.
So we can see the protection will be activated here if it has fallback to the protection OC3 connection. So here I explain the line interface status and the laser on and laser off. So laser on, laser off is like the generate loss of signal we saw before. So we just stop transmitting. You can see what we're receiving. If you have your APS, then the other side should switch on the protection and go to the secondary laser. Here in the, just one thing in the OC3, you have the you have the line loopback, and you have here the local loopback. So this one should not be used. So I think it should be probably removed from this element here. This is a connection that's done internal, and we use that for testing our systems when we produce them. But it should not be in this menu here. So you should use only line loopback or the laser connection here. You have also the status at the other layer. So you have your OC3, then below you have your STS1, your DS3, your T1. So you can see the status at each of the levels. And again, you can see if you have errors there. So you can check that out, make sure there's no errors. Normally there's no magic. If your configuration is done correctly, you need to check if you are connected correctly physically on the remote device. So this is for the TDM connection. Then on that TDM connection, if you have some MTP2 links, then you can look at the status. So MTP2 link status here. You can see if they are up and aligned. Of course, if you see this, then you know it is good. If it is, if they are not up, then you need to start troubleshooting those MTP2 lines. When you click on more details of the MTP2 lines, you can see more information. For example, in-service duration, the current bandwidth you have on the MTP2 links. If you have here errors. So things that we will look for in MTP2. Here you need to make sure that you're receiving frames. So that means HDLC data is received and decoded. Okay? So if you don't see any received data here, that means there's nothing going on that MTP2 link. So maybe you have chosen the wrong time slot, maybe you have chosen the wrong T1, or it's just not configured. Okay, so it could be also not up on the remote side. So we see this sometimes. So for example, the valid frames received are 0 here, and we're trying to send data out to the network. Whoops, not this one. Out data to the network is this one here. So you can see it's trying to send data, but there's nothing received. So normally what we need to check is ask the remote side to bring up the MTP2 link, and then we should start receiving data here. If the errors received are in error, that means there's either the T1 is not good enough, and then the packets are corrupted, or it could be also a framing error on the T1 or E1. Okay? So if you don't choose the correct framing, you may get errors like this as well. So it's not going to be 100% failures, but there's going to be a big percentage of errors here. Other things that you need to do for check for the MTP2 is not here. It's at the media gateway controller level. Because these MTP2 links don't come alone, right? They are attached to an MTP3 interface, okay? And each of those MTP2 links will have a signaling link code value. So, for example, from 0 to 15, so any value from 0 to 15. And when it tries to bring up the link, it will send data on that particular SLC value. If the other side doesn't have the same value, it will bring it down. And so you may see the MTP2 link going up and then down, right? Because it tries to bring it up and then it will bring it back down. So you may see this up and down. Normally, when you see it go up and down, that means it's trying to connect, but maybe there's other information that is not set up correctly. It could also be the point code, but again, this is configured on the media gateway control. To test the MTP2 link, you can select here the data link state, and then you can do disabled and apply states, and this will bring it down. So if you have more than one MTP2 link, you can verify if all the MTP2 links are working normally. You only do this when your links are up, right? So if both links go up, then you can test, make sure both links are working normally. Okay, so then after, if you can't figure out anything with the MTP2 link after, the next steps will be to take a signaling trace And then if you can't figure it out with the signaling trace, you may want to go in the report logs and see if there's any other errors that could cause the MTP2 link not to come up. And well, the other thing we have to mention is that the MTP2 link will not come up until the M2 UA link is up. So we also have to check the M2 UA. So if you go in the status and you click on the, well, there's one more step here, the service access point. So per service access point, you will see information about the M2 UA. And then when you click on the service access point, you will get either the service access point information or cluster information. So normally we want to go to clusters here. In each of the clusters, you will have all the links that are configured. And if you click on peer, you will have all the peers that are configured. The recording. Okay.
My fault. I was trying to let someone in.
Very good. Oh, so maybe the video will be split in two then.
I hit pause, not stop, so I hope
Ah,
not.
okay. So we will we could reassemble them if ever.
Yeah, I can definitely do that if it is too.
No problem. No problem. Well, we will actually edit those videos before putting them online because there's some stuff that needs to be cut off. Links here, you have your various M2 UA links. You can see in the status the interface identifier. So of course, this is an easy mistake to make. So it needs to match what was configured on the media gateway controller. Here you can see if there's a congestion. You can see how many packets are received and sent. So this normally is not super important. You just if there's some packets, usually it's pretty good. As soon as there's some packets here, you can start taking a signaling trace, and you will start to see packets in that signaling trace. If you click on the peer, then you will have all the different destinations for the M2 UA. When you select it, you will see here if it is active. So that's what you are looking for. Hopefully it is active. And then you can see how many times it went up, down, active. So you can see messages here. So normally there's not a lot of things to verify here because the peer configuration is the remote IP and the remote port. So if they match, normally it should come up. If they don't match, then you will see it in a signaling trace that you're sending data maybe to the wrong port or the wrong IP, and you will see the other side also trying to send you information. You can here as well for testing, change the peer state. Like I said before, I think the default is ASP active here, and the only other mode I will really use is shutdown. Because if you use like abort, it's just going to bring the link down and up. If you use init, it's going to stay in the init state. So it's not super interesting when you try to troubleshoot. I think shutdown is the correct mode, completely shuts down the M2 UA. Then you can start your signaling trace and make it active, and you can see all the packets coming into the system. Yeah, so for M2 UA, it's the same. So there's not a lot of stuff to troubleshoot here in the status. You can just see if it's up. And then, like I said, signaling trace will help you to see if you are receiving the packets or at what state of the exchange it is blocking. So we saw in the M2 UA presentation that there's some stages that are being sent. So you have an init session, you have cookie messages, and then you have ASP messages. So you can see at what level it's blocking when the M2 UA link comes up. And if you see the where it blocks, normally you can also see the error. It will tell you in that trace what error is presented to the other side. Okay, so for example, error in number of streams. So usually you will see it in the trace. So it's pretty easy to troubleshoot once you're there. So this is all for the signaling part. It's let's say, fairly simple to set up on the system and fairly simple to troubleshoot. And if you can't figure it out, of course, then you can reach us at Telecom Bridges. We'll help you to figure out what is wrong here. We have a pretty good bunch of experts on our side here to help you on that. So the clocking. So you should have at least one clock into the system to sync the TDM side. Depending on the network, it could be different types of interfaces. Could be the bits clock, the SONET, the T1. So if you're not sure, you can also exchange with us and we'll help you to figure out what's the best clock here. Once the system has a configured clock and you activate the configuration, it will try to qualify the line. So that means just verify if there's not too many errors on the line, and will accept or not the clock as a reference for the whole system. So normally when you have only one, it will make it qualify for recovery, but there could be, you have multiple interfaces and some of them are down. You can see here what is the error and the reason. You can see the unqualified reason here as well. Why is it not chosen as a clock for the system? Once you configured here multiple clocks, you see only one here, but you can have multiple. The system will automatically switch from clock to clock, but it will have a preference to the first one that you have set here. On a 1+1 system, since it's one device that is master, you will see only one device with the clock source. If you see something like this all over, that means it's an internal clock of the system that is, we're using a local oscillator on the device to clock the system. It's not as precise as a service provider clock, but it can certainly hold the signal. So you can still see data being sent in and out. It's just that you may have slips over time, and that in some cases will cause issues. When there's, let's say the unit here is removed from the system, then the clock source will then be captured by the other device here. And since we're using a holdover, that means even if there's a clock change, it doesn't create a glitch in the system. So the clocks are slowly drifted to the new clock if there's a change in frequency. If you then click on the host status here, this is the host is what we call the internal host, the one that is running CentOS. It's also running the database, the web portal, the SNMP. So all these things that are a bit higher level are being handled here, plus the H.248 stack, which has the interface to the media gateway controller. So if you click on host here, you can get information on that internal host. So here it says host license, but there's no license on this type of device, on a media gateway controller to media gateway interface here. So this should also always be okay. So there's no specific license on the host for this. There is then, yeah, this one is also not useful because that's where the licenses are. Processor usage, that's the processor usage of the internal host. So since this internal host is managing all the H.248 messages, so you will get as much of the calls you get. So let's say you have 50 calls per second that are going on, so you'll get a lot of messages being sent back and forth, and then here you will see the processor usage go up in the system. Okay, so you can see if it's in let's say normal operation, if the CPU usage is normal. Okay, so it's a multi-core system, so it can manage multiple threads at the same time. You have also the memory usage here. Normally, there's nothing to do there because all the memory is managed by our application. So there's you can just see the state here. File system. Normally, again, the disk space is pretty large. Almost the only things we keep in there are the logs. And if you have recordings and if you have files, WAV files that are being put there. So this will occupy some disk space, but normally we never get even close to the maximum space we have here. There's, and just to prevent file system from usage from going too high, there's a folder cleanup. So this could be configurable, but normally it has all the information you need here. So if you have too many log files or other folders that are being used by some applications, they could be cleaned up here. But like I said, normally this is all set up from the start. You have network interfaces on the host, but since it's only management interfaces and H.248 interface, there's not a lot to see here as well. So we seldom use this to troubleshoot. Okay, so it gives you just an overview of that internal host, make sure it's okay. And you get also this information with SNMP. Okay, so if you want to monitor it with SNMP, this is possible. Here, if you click on just below host, you have applications. These are all the services that are running on the unit. It's not really important to know what is doing what, because they're all configured automatically in the system. But just to, when you have to troubleshoot deeper, sometimes you need to know a bit more. For example, this TBOM app application is controlling the versioning of the system. So it makes sure everything on the system is running at the correct version. And it also monitor the application. So if ever there's an application that fails in the system, well, this TBOM app will restart it. So this takes only a fraction of a second. As soon as it sees an application that goes down, it's restarted immediately. So these are auto-handled processes in the system. You see there are two applications here because we have a 1+1 system. One is running on one device and one is running on the other device, and both of them will work in pair. Most of the applications are active, but you have some of them that are active standby. So for example, the gateway application, this is the one running the H.248 stack for the media gateway controller. And if it fails for some reason, then the secondary gateway here will become active and take the whole system and control the whole system. Again, this is all done automatically. You only get statuses and reports of what went wrong in the logs. We also have some tools on the console to check those applications. And so we will show you that in a minute. Okay, so this in general is the status that you can see from the system. And we always start with there, so we can see, okay, which module is not working. Is it M2P2? Is it the OC3? And then we can dig deeper to get information on each of these elements. If the problem is at the signaling level, then we will want to get a signaling trace. So the signaling trace helps us to capture traces from the system. So you will be able to capture SIGTRAN. In our case, it will be the M2UA signaling link. We can capture the MTP2 link information. So you can see what is sent on the MTP2 link. And we can capture the H.248. It could be interesting, but normally we get the same information from the SANS system from Metaswitch. So you can see the H.248 message there, or you can see them here in a Wireshark trace. Okay, because all of them will create a capture file for Wireshark. If you start your signaling capture, then you must use SFTP to get the file from the system. So the capture is stored locally on the device. Then you use a tool to get this file out of the system, and you can open it with Wireshark. Or you can use a direct signaling trace using a program called P-Link. So P-Link was done by the same guys that did the PuTTY, and they can send commands to the device and get a live capture. So it's interesting because you can get all the information, all the signaling information live when you want to troubleshoot. So you can see, for example, you can start your trace and then you make a change on the media gateway controller, and then you can see what you receive live. So did the interface ID change, for example? So it's really, it quickens the troubleshooting. So the way to do this is first to connect SSH to the unit. So we saw before how to do this, but here when you connect to the management part, you then need to log in, right? So this is the default password of the system. This password can be changed, and we have the instructions on our wiki how to change the default password of the system here. So you can SSH to the unit management port. Once you have access here, you can do just TB6 trace. So you just type this on the command line, and this will automatically check everything that is on the system and start a capture for all of them. So let's say you have H.248, MTP2, M2UA, IUA configured on the system. You just start TB6 trace, it will capture everything, create a different file for each one of them. And that is okay. That's fine. That's the easiest way to do that. However, if you want to be more precise, there's additional parameters you can put to this command. For example, if you want to capture only MTP2 link information, you can put -SS7. If you want to have everything in one file, you can put another option. If you want to use an older format of not a Wireshark format, for example. So you have all options you can put here and choose more specifically what you want. Then you will do your test. So the signaling trace is not running at all time. It's running only when you start it. Then you will do your test, reproduce your issue or analyze the problem. And then you will stop this application. You need to get it with your SFTP tool like FileZilla, WinSCP, or other tools. You go to this folder, and you see the path is pretty long, but it's always the same path you will see in the other information we have. It's always the same paths here. And there's some shortcut to get to this link here, TB6 trace, because this is the TB6 trace application that we're using here. Then once you get those capture files, you can just open them in Wireshark. It's very useful, of course, because you can filter out packets, for example, MTP2, M2UA, SCTP. And I use one pre-configured because when you try to debug M2UA and your link is up, you can always get some SCTP heartbeat. So you can use something like this to just remove the SCTP heartbeat and concentrate on the M2UA level here to get more information. If you want to have a live capture, then you can use P-Link. So you can go here. I hope this link is still good. I have not tried it, but otherwise you just search for P-Link. Then you put it in a directory, which is in your path. And then you can execute the command, this command here. So here I gave 3 examples of the command. For SIGTRAN, you will use -IP. For SS7, you will use -SS7. And for others, I will show you after that. So the only difference between these 2 lines is this option here. So the command is plink -SSH. The username of on the management port, the IP of the management port, the password. Then you run the command that I just showed you, tb6 trace -IP, but you add the -std out option to push the information to the connection. And then you have a pipe. And then where is your Wireshark application? And then you add some options to the Wireshark application, -K, -I, and dash. You just end with a dash here without any other information here. So what will it do? It will start the TB6 trace application on the device and then pipe everything that's coming out straight to your input which is that last dash here, to your input, and Wireshark will pipe it into Wireshark here. And so you will see all the packets, and we showed you that briefly last week, and we'll show you again this time. Then if you have H.248 here, well, you could use dash H.248 as an option here, so that will work as well. But if it goes on the management port, you can do also a TCP dump. So for example, your SNMP, if it's going out the management port, you can do a TCP dump -I NGMT 0. Okay, so you can put these options here, and that will work as well. Yeah, but any configured interface can be can have an option like this here. This one is for a specific interface, so you can do all kinds of things with these with this tool. It takes you a few minutes to set it up initially because the command is pretty long. It's easy to make a mistake, but once it's set up, it's really useful to help you to troubleshoot. So we'll show you some examples of them after this. So again, with the signaling capture, you can debug a lot of things. If you can't figure it out with the signaling capture, then probably the next step will be the TB report. Why is because when we try to help you from the support team, we usually ask for a TB report. You can capture logs for a specific date, so it doesn't have to be today. It can be in the last week or something like that. If you had some captures that you had done, it could be included here in that report, so you can see traces that were captured some time ago. This is a snapshot of the current call and stack information, so you can see what is currently configured in the system. You do create, and then this will create a file like this, and you can download this file and look what is inside. You will see all the logs, or you can also send it to us in support, and we'll help you to look at what is inside here and figure out what could be the problem. So this TB report, it includes the application logs for the time span you have put. So the you saw the previous applications, Gateway, TBOM app, and all these applications that are running in the system. Each one of them create its own log, and depending on the type of errors that they can see. So for example, Gateway will be H.248. TBOM app would be more versioning and upgrade of systems. Okay, and you have logs here. So for a new user, it can be very difficult to find where are the errors, but for our support team, we know where to look. There's also one specific application that's called TBSys logs, and this puts all the errors that it sees in all the applications. So one good thing is to start with that TBSys log application. You can see if there were specific errors, and usually if you see an error there, you can concentrate on that and fix that first. You get the journal of the host, so that helps you to see if there were physical problems with that host. So it could be a management interface that came down, or a disk full, or stuff like that. So you can see errors here. The TB report takes a snapshot of the telecom unit. So the telecom unit has the SIGTRAN, the MTP2 stack. It has also the configuration of the RTP streams, the TDM, and if you take the TB report, it's going to take a snapshot. And for us, it's very useful because we can see if the OC3 is configured correctly, if it's up, if the T1 is okay as well, and information about the license. So there's a lot of information in that file we can use depending on what type of issue you are seeing. Then it includes the configuration backup. So when you get into the web portal, you can do a backup, and this will copy the whole configuration of all the configurations of your system. And sometimes it can help us to troubleshoot because we can see all the settings that were done. For example, if you change some advanced settings for some reason, we can use this to understand why the behavior is different than what we see usually. So TB report, very important. Like I said, you can look at this file that is created, or you can ask for our help, and we can use this file. The audit logs will help you to troubleshoot if something was changed in the system and it's running differently than usually. So you can see here the list of things that were changed. At the bottom here, you have export current list. So you can just export it and get that to allow it to have it searchable outside. And here you can, the default is to keep these audit logs for 1 year, but they can be erased also if you want that. And if you click here on show at the right side here, okay, you will see something like this. So this, the example I gave here is I'm using the IUA NFAS on our system, and you can see who updated it and in what module, who made the request, so the IP of the who made the request, and then what was changed. So here in the IUA and FAS, there's a lot of information. And if you click on all attributes here, you will see all the information in that IUA link. But here, what we show is only the ones that changed. Right? So here we see that we changed from NI2 to DMS, and this is the only thing that changed at that time in that particular resource. Okay, then we get to the low-level troubleshooting. Okay, so if you can't figure it out with everything else that we've shown here, it is possible to go internally in the system. And we have done it before, right? Connecting the management IP, for example, doing our TB6 trace, setting the initial management IP of the unit using the serial console here. We can connect SSH and SFTP to the internal host. When you do all of this, you get to that internal Linux OS, which is running CentOS 7. Okay, so the OS run here is not really important, but it's interesting because it's a Linux version, and it's easy to work with if you have worked with other Linux versions before. This internal Linux host here has a lot of things, a lot of applications that are being run here. One of them is the H.248 stack. So the connection to the MGC, the process will be running here in the internal host. The other part that we have here is the telecom unit. Okay? So these are two separate modules which are interconnected inside. And this telecom module is the one that has the TDM connection. So the OC3, DS3, T1s, E1s, it has those connections. Here, it has the RTP connection, and it has also the SIGTRAN connections. All of them are connected to the telecom unit. So if you want to look at H.248 information, it will be at this level here. If you want to look at TDM, VoIP, SIGTRAN, it will be at this level here. So low-level troubleshooting in the system. So you see the host part here and the telecom unit part here. You will connect inside here with management 0. You will get the same connection if you connect with the serial console, but normally we only use that to set that management 0 IP. So you can SSH, SFTP, HTTP to this internal host here. If you want to reach the telecom unit, well, you have two ways to do that. One is to use this internal interface, which is always done in the system, and it's using int0, but it could also be another name here, but it will have the same IP address. Okay. Yes. Okay. So for TSG 800, it's called VLAN 3, and for TMG 3200, it's called int0. Okay. So it's possible to connect to the telecom unit from that internal host by telnetting here to this IP, and then you're at the telecom unit level. If for some reason this doesn't work, there's a backdoor here that you can use, and you can use Minicom. Minicom will connect serial port to the device here, and you will have the same interface as the IP here. Okay? So this, of course, we seldom use this interface. So things you can do here on the internal Linux host. When you log in here, you can see it's running all the applications. So the application you saw before, like Gateway, TBOM app, and all these applications are running here. But since it's a CentOS host, you can do those commands like ifconfig, yum update, varlog messages, top. These are all standard Linux commands, right? So, for example, varlog messages can give you global system messages, power up logs, Ethernet driver status. So these are all information you can get here. Yum update is to update the Linux host. So here in the OS, we have some Linux packages. We don't use all the Linux packages from a standard installation. We use only the packages that are necessary to run our software. And we update those packages sometimes. All right, so we follow the CentOS release schedule, and then we make some changes into our drivers for maybe for security or other things. And so we update it, and sometimes you can do a yum update here to get the CentOS to the right version. So normally, if you don't update the system, this is not necessary. Sometimes when you get to a new version, we force the system to also update the Linux host here. You can do here a yum update from the command line, but you can also do it from the web portal. Maybe we can show that later. We also have a special service that here runs all these applications, and it's called TB Toolpack. And then you can check the status of this service, make sure it's running. So if ever you get a problem with some of the applications, you can do status here, but we have other tools that we will show you. We've shown you this as well last week. So there's a shortcut to get to the current log directory. So if you just type TB setup, it's gonna switch you to the correct folder into the system for all the logs. So you can go manually check the log. TB bin will get you to the application directory, not as useful for these systems. Configuration database backup. So you saw from the web interface, you can go and get a configuration backup. This will copy everything that is in this configuration database and dump it into a SQL file. However, if you don't have access to the web portal for some reason and you get access to SSH, it's possible to do the same functions. And since it's running a MariaDB or MySQL DB, it's very straightforward to do if you know the commands. So if you connect to that system and you can do a manual database backup here, so you do MySQL dump, the password and username of the database is always the same. And then you, oops, I forgot to change this here. So this should be OPT toolpack 3.2, right? So _3_2 here. And this will be sent to a SQL file. So this SQL file here contains all the configuration of the system. It can be reused on this same system if something happens with the database, or it can be used on another system to upload it and copy the exact configuration from this system. The database backup includes the audit logs. It can be loaded on any unit. It is available in the TB report as well. And so you have this. So you can see also, you also have other MySQL commands. So you can see if the MySQL server is up by doing some commands here, or restart it for some reason. Okay. if you want to access this database, it's possible, right? So you do MySQL and this command here. And then it's, of course, again here 3.2, okay, _2 to access the current database. And one of the things we do, well, normally we don't need, of course, to go in the database, but what we do sometimes is when we get a database from a customer and the customer has changed the password, the root password, we can replace here the root password with a known one so we can access the database. Okay? Because the password of the web interface is inside the database. You can't access it unless you have the password. But if you have the root access to the system, then you can change that password. So it's not the password of the SSH port, it's the password of the configuration database backup. Okay. On a 1+1 system, then you are set with two different devices, and they will communicate together with ETH0 and ETH1. So there will be communication both ways on the devices. So there will be some heartbeat from the telecom unit to the telecom unit, but there's also information that is exchanged from the internal host of the two devices. And when we were looking last week at the web portal and the ETH interfaces configured on the system, on the IP interfaces configured on the system, you could see those IPs that were there. All right, so you see the default, these could be changed, right? These are the default IPs for the primary ETH0 network and the secondary ETH1 network here. Okay? So there's going to be some messages exchanged between here and here, making sure that only one of them is active and who is active in the system. We can have, in a system like this, we can have applications running on this internal host and on this telecom unit. Okay, the messages will be sent this way. We could also have some applications running here, some application running here, and it will be controlling the same telecom unit here in the system. This is all handled automatically in the system. One of the things I've been using also is that sometimes you don't get access to the secondary device here. So it's possible to access the primary and connect internally here to the secondary by using this interface that it exists in the system. The reverse is also true. And so this configuration is done at startup. So when you configure the first device, you do like the initial host role. You will say, I am a primary system, and it will suggest you these IPs. So you can just accept, and that's fine. When you connect the secondary device, you can say, this one is a secondary. And then you will say, I want to connect to the primary device, and these will be the default IP. So it will be automatically connecting to the primary device if those Ethernet ports are connected. Here I show them directly connecting between the two devices, which is the suggested configuration, but it could also go through a Ethernet switch here, and it has Ethernet connections going this way and this way. And then the only thing is on the switch here, you need to configure the VLANs, and the default VLAN are 710 and 711. So it's possible to do something like this as well. And of course, there will be database synchronization. So we saw the database on one system here, but there's always on a 1+1 system, two databases. They are in sync, so the data will be pushed this way or this way, depending on who is the master, who has the master database at that moment. And it's atomic change here. So if there's a change that is done here, it's done as well at the same time on the secondary device. So when you configure one system, you make sure that all your systems are configured. The SIM can be also configured from this side, and the configuration will be pushed both ways in the system. If you connect on the telecom unit, so you go one step lower and you connect here. So you can do telnet 172.31.1.1 to connect to the telecom unit here. And this telecom unit runs, like I said, the SIG signaling stack and also has the media. So it has the TDM media and the RTP media on this side here. Sorry. And when you connect to the telecom unit here, now it's not a CentOS Linux host. So you will see that the default commands don't work normally. I mean, the default Linux commands, right? So it has its own set of commands, and you can do exclamation mark, interrogation mark, or I think you just type help and you will see the different commands that are available. Of course, it could be very cryptic. Here, what I've shown is things that we use sometimes. So print info gives you just information about the unit itself. It tells you what type of mezzanines, hardware mezzanines it has on the system, like the IVR DSP, VoIP DSPs, serial numbers on the device. Print boot will show you which version it's starting on. Ports, physical ports on the system. INET is IP interfaces that are configured at this level here. VLANs, right? So you get some information, low-level information about the system here. It's, I would say, pretty rare that we need to go all the way down here, but one of the things we use it for is to capture a media trace. Okay, so there's two ways to get a media trace in the system. One is using the, let's say, configured tool of the system. All right, so you can go in the web portal and configure to capture data. Now, for an MGC, it's a media gateway controller. It's pretty difficult because you need to input here in the termination name section. You need to put the right name of that particular termination you want to capture. Okay, so you need to know already what you want to capture before you can do this. If you know and you can have it, then you need to go in this from the web portal, and then you can enable call recording. So you go in the gateway section, advanced parameters, enable call recording. And you click here on, well, you put the termination name here and you activate the configuration. If it finds something on this particular termination, it will record it. And it will record it this way. So when you select one particular termination name, it will record the data that is coming in from the TDM side, and it will record the data that is coming in from the RTP side, of course, if the two are connected here. So you will see everything that is coming in. So when you get the files, and the files will be wave files in a specific folder, which is shown here. These wave files will have information about all the stream that is coming in. Right? So this can be useful for hearing. Sometimes the customers can say, well, there's some noise in my line. So you can see if the noise is coming in from outside the network here, RTP or TDM, and you can debug this. We've used it before as well to debug some fax processing. So there were problems with fax, so we can record the data here and be able to figure out why the fax is not working. And it's a wave file. So once you have the wave file, you can do all kinds of analysis here. Sometimes we use it for looking at the DTMF that are there. So you can use like Audacity and you can do a spectrum analysis. You see the frequencies that are received and be able to analyze that. However, since you need to put the termination name here, sometimes it's a bit difficult. And the better way is to do a media capture. Okay? So when we do a media capture, we will then go on the RTP processing here. We will configure it so that we can do a port mirroring. Okay, so the port mirroring will usually take data coming in from VoIP and in from TDM and send it to the internal host here. And then we need to start the TCP dump to capture that information. So this is, I will show you how to do this, but it's really interesting because then you get all the data that comes into the system and you have your data in a Wireshark viewable file. Because yes, okay, so what I have explained here is that when we capture ports here, well, you will not only see the media, but you will also see the SIGTRAN traffic, you will see the H.248 traffic if it goes through here, so you will capture everything. You will see also, sometimes we have debug cases where the ARPs are not being replied, so you can see a harp going out but not coming back, so we can see all that. So it's really like a low level capture. It's very similar than to capture here if you have an Ethernet switch and you do port mirroring, right? So it would be the same process as this, but you don't need an external device to do it. It can be done internally like this. So let me show you, sorry, let me show you how to do this for a TMG 3200. Okay, because since now we're at the telecom portion, there is a difference between a TMG 3200 and a TSG 800. Okay, there are small differences here. First, you need to have your SSH access. Then you need to telnet to the baseboard, the telecom board. Okay. Then you need to run this command. And the command will be different depending on what you want to capture. So let's say you want to capture both VoIP 0 and VoIP 1, you will use this command. Okay. And you can see the difference here between these elements here. This is what is being, I think it's transmitted, and this one is received. Okay. And it's a mask of what you want to capture. Okay? So most likely you will want to capture VoIP 0, VoIP 1. If you do this command and the 88E monitor by itself, you will see the parameters. But on the wiki also, we show you on our documentation pages, we show you how this is done. And this is the most useful command that you can use. Okay. So this is the VoIP 0, VoIP 1, and this is where to send the data. And on the TMG 3200, where to send the data is on the internal host. And then we can do a command like this on the internal host, and this will create a file which will have all the information coming in from internal 0, which will be the data that is being captured here. For a TSG 800, you see the command is slightly different. You still need to connect SSH, telnet, but the command will then be for VoIP 0 and VoIP 1, it will be 0x18, and the internal port will be 11 instead of 8. And then you see the TCP dump capture here. The internal interface is VLAN 3 instead of int 0. So this is the small changes from a TSG 800 and a TMG 3200. Okay. We have all the details on the documentation, but we will show you some examples now on the system.